So we will move on now to Bharat Biswal, who is going to bring us into the world of pre-processing. He's going to go over some different steps that are best practices just in general and point out some ways that these are best practices that are specific to using naturalistic data. So thank you very much for being here, Bharat, and take it away when you're ready.
Thank you. Good morning. I would like to thank Dr. Tamara van der Waal and Ian Liebenthal for inviting me to the symposium. Once upon a time, I used to work on resting state, and after reading many of the papers that was presented and several speakers who spoke, with Shindy in our group, we have been working on the movie data sets. So today I'll be mostly speaking about pre-processing strategies. So in some way, the pre-processing strategies are very similar to what is used in resting state. So there are many similarities. So like you have the raw fMRI and the high resolution T1, and then we use a series of processing strategies. And in movie watching also, it's similar, but because the questions that are being asked are different, I'll try to cover places where we use slightly different processing analysis methods for movie watching. Right? So the first one which is used is like realignment or looking at head motion related changes. So in this case, like there are many different ways to analyze, but like one can think of where you take a fMRI time series, take like the first or the fifth, one reference vector, and then do a least square fit to estimate the motion. And then you can get like X, Y, Z translation and the 3 rotation parameters. And then what do we do? So there are mostly like 2 approaches. One is censoring, where what you do is you do not use that data point in your analysis, but you use the rest of the data points. The other one, which has become popular in resting state, is called scrubbing, where basically when you detect the time points where there was motion, you basically throw away those data set, and then your time series basically becomes smaller. I think that in movie watching, that's not a good idea, because you are introducing different phase differences, which can increase your correlation or can even reduce your correlation. So perhaps, like, of course, like if there was no motion, that is better, but if one has to choose, in my opinion, perhaps censoring is better. The other step which is used is segmentation, where you take the brain data and then segment into gray matter, white matter, CSF, and then do your processing. Again, in this, we are making an assumption, and the assumption is that most of the information that we are looking for is in the gray matter. That assumption may or may not be true. So again, depending on the question, while you are doing the segmentation, keep that in mind. I think that the co-registration is fairly straightforward. It's like you want the fMRI data set to co-register with your anatomical, so that you can do a good comparison of the location of these differences. Then is the normalization, which is like taking, how can you compare different subjects' brains? So if it's adult's brain, then we can use the MNI template to transform all the data to do this. Of course, if one was to just study like small children or so, then one can make a template for children and then use that. The spatial smoothing, again, like for traditional 2 by 2 by 2 or 3 by 3 by 3, a Gaussian filter is used to minimize noise and increase the signal to noise ratio of your data sets. Then is the regression. I feel this is where there's a big difference between how we analyze the movie watching data set versus resting data set. Again, in movie watching, depending what is the question that you are asking, you should use those signal as your, noise regression or regression of interest. This just an example. If my hypothesis was that based on the kind of movie one watches, different subject would have similar head motion, then maybe head motion should be the signal of interest. Having said that, I know there is a paper by Dr. Van der Waal where they show that it's not the case, right? So then, you should use that as a nuisance regressor to minimize any kind of motion. Similarly, if one thought, again, if like based on the movie you're watching, maybe there would be some change in the heart rate, then that would be something of interest and one should not regress. So I feel depending on the question that you are going to ask, you should decide which one to use, which one not to use. Many people have used, for example, the mean white matter signal or the mean CSF signal or the global signal. Again, depending on the hypothesis, you can or should not use one versus the other. So this is just like a brief outline of some of the analysis that we have done using the HCP data set. So the minimal pre-processing pipeline for the HCP movie data set comes with like gradient distortion correction, motion correction, EPI distortion, brain masking, register to T1, and then transform to the MNI space. The question where we have to decide is what kind of spatial smoothing should we use? Then like whether one should use temporal filtering or not, and even if one was to use temporal filtering, should it be between, well, first of all, should you use temporal filtering, right? And if you were to use, like some people have used between 0.01 to 0.10, as is done in resting state. Some others have used between 0.01 to 0.15. So depending on that, one should use temporal filtering. Whether one should use global signal regression, again, there are several papers where people have used. Personally, I don't think a global signal is a good idea because there are papers which show that using global signal regression can introduce false correlation in specific regions. But these are the ways it has been done, and depending on what you would like to do, you can choose. last but not the least, I would like to thank Prateek Shen and the different members of the subcommittee. I think I have left several names out by mistake, but others who have contributed to the white paper that Dr. Vanderwall mentioned and helping with the presentation. If there is any question, I'll try to answer. Thank you.
Thank you, Bharat. Any questions? I'm going to ask one, actually. When you work with movie watching data, how do you do your temporal filtering?
Typically, we don't use temporal filtering.
Okay.
But if you, what we have found is that if you don't use versus if you use 0.01 to 0.15, there's not much of a difference.
Okay.
Yeah.
So you like to be more relaxed with that than
Yeah,
the rest of the
yeah.
state? Okay, cool. Very good. Thank you.